becoming too quiet. Okay, is that better? Is that all right? The other thing I want to do is keep this informal, so feel free to interrupt me if you've got questions. If I feel that the answer is coming up in a slide or two, I might put you off, but I'm very happy to take questions all throughout. I'm going to do two things in this talk. I'm going to talk through what is a sort of a large project that we do in the first year environmental science course, so you can get some idea of what our learning objectives are and how we approach achieving those learning objectives. And then Jason asked me to speak a little bit at the end about just what my experience is teaching first year students. So in other words, sort of speaking a little bit to the prep that they come with. I've kept that bit very short, but I'm happy to answer questions if that's of interest. So next slide. So there are a bunch of learning objectives that I'm trying to achieve in the first year environmental sciences course, but I've picked out a few that are relevant to the project that I'm going to describe here. So I spent a lot of time really trying to develop the idea of critical thinking in environmental sciences with these students, so that they understand what does it mean. What does critical thinking in environmental sciences mean? How is that different from critical thinking in other disciplines? What are the sort of unique things about environmental science? And that, of course, leads us into a variety of basic philosophy of science kinds of things. So that they start to understand what is science? How is that different from non-science? How is that different from pseudoscience? In environmental sciences, of course, we have the word sciences in there, environmental sciences, but when you get down to trying to solve any of the world's great problems, it's obviously not just science that comes to the table, and it can't just be science that comes to the table, and that's something that students really need to have hammered home to them, that science plays a role, it has a part to play in these great debates, but it doesn't give you the answers. So I spent a lot of time developing those ideas. And along the way, of course, we developed the ideas of what are the limits to science, so that they understand that science isn't infallible, that there is room for legitimate debate among environmental issues about the science involved. And that debate then, of course, involves an understanding of what constitutes scientific evidence. How do we judge scientific evidence? How do we know whether it's credible or not? How do we compare conflicting scientific evidence? So how do you weight differences in the evidence, the strengths of the evidence? And the last bullet I have here is scientific communication. That's a fairly generic term, and it probably engenders a whole variety of ideas in your head. But really, what I'm teaching here is not so much to them about how to write about science, but what are the differences between kinds of scientific communication? What is peer review? How does peer review work? Why do scientists always hold peer review up as something to be aspired to and to be given weight and credence to? And how does that compare, for example, to science journalism or newspaper articles, that sort of thing? And in fact, one of the exercises that I make them do in the first year is they take a newspaper article that describes some new scientific finding, and then they go back and find the original paper on it, and they do a comparison of the two pieces. And then I make them do the opposite. I make them find a science paper and write a journal article about it, so they see how difficult it is to translate all the nuances and complexity of a scientific article into 500 words that's supposed to appeal to everybody. So those are the kinds of things that I try to accomplish in that part of the course. Jason, next slide. What I'm going to describe here is I'm going to describe the process that I do for this project and what the project entails. I'll show you some of the outcomes of it. So the kind of big picture overview, what I do is I start with a couple of what I have in quotes here, lectures. Really what it is I effectively use like a chalkboard and chalk. And I pose to them the question, how would you know this coin, I have a coin in my hand, how would you know this coin is a fair coin? what does it mean to be a fair coin? How would you test that idea? And I'll show you. I do that. It takes me a couple of lectures because we do it. It's basically pulling the information out of them, not pushing it to them. So I probably spend maybe, my lectures are 80 minutes long, so I probably spend 160 minutes or so on that problem alone. I'll give you a real glimpse, a snapshot of what that looks like. And then I give them the main idea of what I want them to test, the experimental goal. I give them a couple of constraints that they have to live with, and then within those constraints, they work as groups to come up with an experimental design, conduct the experiment, and then they present the results at a poster presentation. Oh, sorry, I skipped a step in here. This presentation and critique. Before they do the experiment, but after they do the design, they stand up as a group and they explain what they're planning to do, and that generates a lot of discussion. Largely from my part, I bring up my race issues and we thought of this, what would you do in that case, this is why that's a bad idea, and we go through that for each group. After they've conducted the experiment, they present a poster paper. My class, I should have said, my class is about 130 students. These are groups of usually 5, maybe 6 students. And what happens is the first day of the week, half of the class presents their posters, and the other half of the class goes around and does peer review of their posters while I'm grading. And then the next day of the week, I lecture twice a week, the next day of the week we swap roles. And so across the week, they've all presented their results, they've all seen each other's results, and they've all prepared peer reviews of those results. Thanks. Okay, so here's just a real sketch of how I developed this idea of a hypothesis and testing a hypothesis. I said I start out with a coin, and I asked them how are we gonna know whether that's a fair coin or not. So we spent some time talking about a null hypothesis, and then we talk about what our alternative hypotheses might be. So in the case of a coin, of course, the alternative could be just that it is not fair, or it could be that it's biased in one direction or another. And we talk about the significance of having a directional hypothesis, why that's important, why it can be powerful, but why it has to be justified. So this then leads us to the idea about testing the hypothesis. And I'm sure this will probably be familiar to many or all of you from your introductory statistics course you took some years ago. But we spent quite a lot of time talking about these two errors. Right? So on the left-hand side here, you have the results of your experiment. At the end of your experiment, you're either going to reject the null hypothesis or you're going to fail to reject the null hypothesis. And along the top there, you have the true state of the world. Either the null hypothesis is true or it's not, but you can never know what the true state of the world is. All you can do is make an inference. And two of those inferences are correct. You can either reject the null hypothesis when it's false, a little tick mark over there, or you can fail to reject it when it's true. And the other two constitute errors. And we talk a lot about errors, so we talk about which one of these errors is more important. Why would you think one of them is more important than the other? How do you control those errors? What are the things you can do in an experiment to make one of those errors bigger or smaller? And eventually we then move on from this idea. So again, I spent quite a bit of time, maybe a half an hour probably, talking about this idea, but I'll give you a minute. Next one. So then I get them to think of, they talk to in partners in the class for 5 or 10 minutes. I get them to think about what experiment